All right, let's take a look at the last problem from the Google Codejam 2022 qualification round. Looks like this one is, substantially harder. Only 180 people have solved it, so hopefully I can do it. We have a cave. It's a graph. Sure. Interesting. Okay, we want to know the number of edges. And we can either go to a random, so we can see how many edges. I see. Okay, we know what node we're in, and we know how many edges there are out, but we don't know where they go, I guess. Interesting. Within a factor of a third. Okay, seems cool. Seems hard. So we know the number of vertices, and we know how many moves we're allowed to make. Okay, we get to know our current index and how many edges there are. And we get 8,000 moves. But there's 100,000 vertices. And I guess they could just be n-squared edges. Interesting. Yeah, so one approach would be to just randomly teleport, just always teleport and keep track of, the number of edges in the rooms that you've seen. So if k was bigger than n, this would be a great strategy, but we could just visit all the rooms by randomly teleporting, and then we would know exactly how many edges there were, right? Just like the sum of the number of passages in each room over 2, because each edge is counted at both sides. But n is 10 times as much as k, so we won't see the majority of the rooms if we follow that strategy. What I'm tempted to say is that we should do a random teleport and then a walk 4,000 times. And then we should see most of the big rooms that way. And I guess imagine we just had a cycle. Then every room looks the same. They all have 2 edges. We would see that. Interesting. Yeah, so I guess an advantage of walking is that you see rooms with more edges more often, right? I think a teleport and a walk is just traversing a random edge, essentially. That's not true. I think. T goes to random Maybe it is true. It would be good to walk a random edge, because then you would see, the nodes of the highest degree, which are the most important for counting the number of edges. Yeah, I think there's no guarantee that the graph is actually connected. Oh, I can pick which room to teleport to. Oh, that's okay. That seems very important. Uh, Math is hard. Okay, so what I think I want to do, and I'm probably just going to try this and see if it works or not. Yeah. Oh, I see. You do have a starting room. Okay. Okay. We know what room started. Is it random? Arbitrary. I don't know if arbitrary is the same as random. Yeah, okay. A bunch of includes and stuff. vector. Maybe that's it. Some utility for pair, technically. We need assert. And we need random. Okay, looks like this is working reasonably well. Give it a try, I guess. Getting pretty close. Cases. Cool, looks like that was right. Yeah, so I can't like prove that this works. It does, I think, make some sense. Right, so I mean, I'll talk through the intuition again, but you know, it would be nice to see some math, which I'm not going to do. So, you know, the first idea is just like teleport randomly around, and you'll see a random sample of rooms, and then that should give you a good estimate for the total number of edges. Right? It's just take the average number of edges you saw in the rooms that you went to, and you know, multiply by the total number of nodes. Okay, so that sounds nice. The problem with that is that there might be some like outlier nodes with a lot of edges that screw you up. You know, so for example, if the graph was just a star where you had one node in the middle that was connected to everyone, and everyone else only had one edge, if you teleport around randomly, you're not going to get the middle. Right? You're only going to see the guys with one edge, and then you're going to be like, I guess everyone has one edge. And then you're going to be off by like a factor of 2 because the middle node has like half the edges. Right? So that's the problem with that idea. So the fix for that is we don't just teleport around randomly. We also take random edges. And you know, the reason that is helpful is because If a node has a lot of edges, then we're likely to come across it when we take random edges. Right, like in the star example, it's very unlikely that we'll just teleport to the star. But if we take a random edge, then it's certain that we get to the star, right? Because every edge is part of the star. So that's what I did basically. I spend half my budget teleporting randomly and half my budget walking from the random teleport. And every time I actually get to a node, I write down how many edges I saw from it. And also I keep track of which nodes I entered randomly and which nodes, right? Because these are the ones that I'm going to average to get an estimate for the nodes that I didn't walk to. Right? I don't want to average in these guys because I didn't get to them randomly. I got to them by walking through edges. And so the more popular nodes are more likely to be hit in this way. So if I use them in my average, that would be too high. So then I go through, and all the nodes that I actually saw, okay, I know how big they were. All the ones that I didn't see, that's too bad. I need to guess. And then my guess is going to be, for all the nodes that I hit randomly, figure out the average degree there, and then just assume that that is the average for all the unknown guys. Divide by 2, because I'm counting like the sum over nodes of the edges that they see. Like every edge is going to be counted twice, right, in 2 nodes. So that's why I need to divide by 2. And that's my guess. And I have no idea, what the chance that this works is. Intuitively it makes sense, but it's hard to say, how close this is going to be to the right answer. But it passed. Right, so they give you this whatever test cases this thing is running. It seems to do well on those. And it passed the actual test set, so I guess it's pretty good. All right, that is it.